this show now. First, I would request one thing, that you switch off or put your phones to silent so that we'll have a nice and peaceful show. Okay, so good afternoon everyone. Everyone had a nice lunch? Yes. So first of all, I welcome you all to this science exhibition, mega science exhibition, that is Vigyan Samagam at the Nehru Science Center. And we, the team of TMT, outreach team of TMT, will be presenting some light demos, optic demos and telescope demos for you. So TMT is the 30-meter telescope and we are the outreach team for that.
Mamma mia! What did you say?
Oh,
Optics, light. I love light. I love optics. I am Galileo. Galileo.
I can't believe my ears.
Are you going to show optics? I love it.
Yes.
But what is this 30-meter telescope that you're talking about?
It is a very big project. It is a coming up project, sir, and India is a part of it.
All right. And what are these words? 30 I can understand. What is this meter?
Oh, I see. So I guess in your era, sir, they were using inches as the unit of measurement.
Yes, of course.
We use meters as the unit of measurement.
All right.
Which is, I suppose, 1 meter equals to approximately 40 inches.
Oh, that's quite big. We had foot, which is equal to my foot.
Yes.
All right.
So it's 1 meter is equal to 40 inches. That's the meter unit that we use.
Lovely. And what do you have to show?
We have some light demos and some optic demos that we would see. Would you allow me that I'll demonstrate in front of all my friends, sir?
Of course, I have just appeared here. It is your stage. You please take over. I am interested.
Yes, please.
Can you see a laser point? Can everyone see a laser point? Yes. Yes? Now, when the light will go on, yes. Can you see the path of the laser now? No? Okay. Let's see the path of the laser. So how is it traveling? How is the light traveling? Straight line. Why? It can go wiggly. Can it? Yes. Can it bend? No. Is it going in a straight line perfectly? Line. Is it going in a perfect straight line? Yes. Why? Okay. Now, can you? Would you want to like to see how this line bends? Yes. Okay. Can everyone see? Can you see two laser beams? Yes. Yes? Parallel to each other? Yes. Now see what happens when I what is happening? So what do you think is there inside the water now? Is it? Concave or convex? Is it lens? Why are you sure that it's lens? Okay, we have one more interesting thing. What is happening? What is happening? Yes? What was happening before and what is happening now? Okay, so what do you think are these two things? Yes. So when they were converging, it was and when they were diverging, it was a concave lens, sir.
Right.
Yes.
I know these things. These are,
Do you?
lovely inventions by these glass makers. In fact, one glass maker that I know of, I don't know him personally, but he has made an instrument which can combine two lenses, and it can make things which are far away look bigger and brighter.
Oh,
It's an amazing, yes.
Oh, wow.
I was using it in my times to look at these objects in the sky, and they were
Telescope.
wonderful. What?
Telescope?
Yes. I have heard, not I, we have heard and read about these things.
No.
Those challenging days in your time.
Yes, it is called perspiculum, and you call it telescope now?
Yes,
Yeah.
sir.
Oh, that solves one mystery. Okay.
So, this is
Okay. You have so many magical things now.
before showing this. So, this is what your perspicular.
Yes, this is it. This is what I had made, but mine was made of wood. And the lens is here. It is still glass, thankfully. Okay.
But this is what we have made.
Okay.
So nowadays it is called as Galilean telescope.
Oh, really?
Honor, sir.
Wow, I'm so happy.
So, if you allow me, I would like to tell you something about
Of
the
course.
Galilean telescope.
Of course.
So, at the front, we can see this is objective lens, and at the end, there is eyepiece from which we can see the object.
Okay.
So, we have to focus objective lens towards our object which
Right.
we want to see,
That's right.
and from this we can see the object more clearer, sharper, and big.
So I'm so happy that laws of physics have not changed in 400 years. I hope they never changed in the history of the universe. So that is the glass lens. It's quite big. And the eyepiece lens I see is small. It's just enough to put light in your eye, and I can actually see. Wow, this is a nostalgic time. Good.
So this, you can see this, but we have to
I cannot see inside it. So
we have to tell our friends that how this works. So,
that
would you
is
like?
why.
You can see here. Lights, please. So here at the front, as like this telescope, we have placed one convex lens, and at the end here is the eyepiece. So this is a very low cost and simple telescope made from what? You can see, made from water bottle. Okay. So as it is transparent, you can see how it works, how the rays coming from the objective lens and fall on the eyepiece, and you can see here also they are, what happened with the rays? They are converging. Okay.
Wow, what a lovely demo. And I love those green torches that you have.
Yes, sir.
What
That's
is
called-
that? It is so
that's called
strong.
a laser. It is a remarkable discovery by humans these days.
Wow, wonderful. What more do you have? Show me. I want to see what's happened in the modern times.
Are you wondering how did we make 30-meter big telescope?
Oh, yes, that's the 30 part I understood, but I did not understand also. All right, please tell me.
Okay, so in your times we used lenses, I guess.
Yes.
We have not used lenses for the 30-meter telescope.
I was wondering how could you make a lens which is 1200 inches big.
So what
30
we have
meters.
used? We have used mirrors.
Okay.
We have used mirrors to make a 30-meter diameter big mirror.
A mirror? Why a mirror?
See, now we'll show you some demonstrations about the mirror and tell you why a mirror and why not a lens.
Why? How?
This is a mirror.
Okay. Yes.
It's a plain mirror.
Yes. Okay. I look nice.
Okay? So now when I shine a laser here, what is happening at the end point of the laser? What is happening to the end point of the laser? You can see a spot. Now imagine if this was a big mirror. What would have happened? You want to see? Yes.
Oh. Yes.
Now where is the laser pointing and where is the spot? Yes? Now this is a plain mirror. What will happen if I use a concave mirror and a convex mirror? Galileo, can you help us please?
Yes. I'll be very thrilled to use these torches.
It's not a torch.
It's a laser.
Laser. Okay, if you
Now,
want to call it that.
You'll be also amused to see that I'll make 3 types of mirror out of this piece of mirror. This is a plain mirror.
I just point like this and
Yes. You just start.
okay.
Yes. Now, can you see both the laser points? Yes. What will happen if I bend this mirror? Convex. What is happening to the 2 rays? So concave mirror is doing what?
Is diverging the light.
Is
Diverging the light.
Converging.
it is converging the rays, and the convex mirror,
Is diverging.
you can see both the points at 2 different sides. Look at the points. Are they? One is that side and one is this side. And on a concave mirror,
They're still on both sides, but
but you can see a point
bring
here
it closer by.
near the mirror here where the 2 rays meet. Can you see? Okay. So the wonders of mirrors is we don't get.
I already know that.
So why mirrors? Why not lenses?
That's what I'm wondering.
Okay. So when you use lenses, what did you see about the moon?
Moon was. I could see the patches and things very clearly. I could study it for a long time. It became brighter. But yes, I was very disturbed by there's some colors which were coming, and I did not see them with the naked eye, and I was wondering why are there colors around the moon when I see it through my perspiculum.
Exactly. So what did Newton discovered was prisms disperse light. When white light enters into prism, it is broken into different colors. And similarly, the lenses also have the similar properties, hence they give a chromatic aberration.
So you mean this light is made up of colors?
Yes, it is. Would you
Really?
take some demos?
I've always wondered why the rainbow suddenly appears with so many colors. Maybe it could be related to this.
Yes.
Is it? Okay.
Let's see.
Let's.
Sorry, I'm very old. I don't know much stuff. So please help me. Even all of the kids can help me here. Wow, that is
Can you
different
see
colors in your hand.
colors? What 3 colors are these?
Red, blue.
red,
Green, blue.
green and blue. Yes. These are 3 colors.
And there is a white color there. I don't want it.
Okay. So, can you think of making different colors out of these 3 colors?
Yes. Yes.
So, every day when you go to school, what kind of shadow do you see?
Black.
Why did I ask what kind of shadow? Why didn't I ask what colored shadow? Shadow doesn't have color, you just said it's black.
Shadow doesn't have color, of course.
Black is
Are you asking me as a physics person or as a lay person?
Now, these 3 colors, when I point them to the ceiling or to the board, you see the board. Yes? What will happen?
Oh,
What different colors can you see?
I can see. Can you bring it closer to the screen? Is it? Do you have magic in your hand or
Your hand
in
can
this
do that
in
too.
this fire that you have here? Oh, yeah, it is my hand. And so many colors coming out of my hand. What's happening? Oh, right.
What different colors can you see here? Are all these colors present in this panel? What 3 colors could you see in the panel?
red, green, blue.
How did all these colors appear on the screen?
Oh,
Which colors can you see? This is a similar arrangement with 3 LEDs.
I want to play with that fire.
Red, green, and what colors can you see on the screen? Yellow, magenta, and the bluish color you see that side is called cyan. Yes? So what are these lights contributing to? Which light is contributing to what? You saw pink shadow, green shadow and cyan shadow. Did you? Had you seen different colored shadows before? Or you had seen black colored shadow? Did you see different colored shadows now? Yes? So, which color must be making a yellow shadow?
Red and green.
Which color must be making a magenta shadow?
Blue and red.
Let's see. Blue and green makes. Blue and green makes.
So you're covering the red.
I am covering the red and making cyan. I'll cover the green to give you blue and red to give magenta, and green and red to give
Oh.
yellow. So, different colors will give you different shadows. Do you know these colors are known primary colors?
Yes.
And what are those colors? Yes, very good. So now I'll show you 2 more interesting things. Okay, now this is an interesting thing.
That is beautiful.
What colors do you see? Blue, green and red.
Cyan, magenta, yellow and white.
Cyan, magenta, yellow and
White.
white. Good. Now, what colors you see now?
Black,
red, green, blue, cyan, yellow, magenta, and what was in the middle? Yes. Now, what was the difference between the two images? Now let's ask some questions. And do you like these badges? Yes. Yes? You want these badges? Yes. You want that? Okay. So, the first question is, what were the differences between these two images? Yes.
One was due to the
What was the differences?
one was due to scattering of light and another one was due to spectrum of color. Ma'am.
Okay.
Ma'am.
Anything else?
Ma'am, the center of the shadow was in the first one it was white and second one it was black, and the first one the primary colors were outside and the secondary were inside, but in the second one the secondary were outside and primary were inside.
Yes. Good observation.
Yes.
And what? Then now the second question. Why? Yes?
He has an answer there, back there.
Do you
Yes.
want to answer?
Because it was opaque.
Why was it black and why was it white?
Because the ball was an opaque object, and behind an opaque object then we cannot see things. That's why it was black.
Okay. And why was it white?
And because it was transparent.
Is it transparent?
No.
Yes? You have got a badge, I'll give you.
Because in first one the light all the three lights were passing and they merged and formed white, and in the second one the lights were being blocked, and when no lights were present it was black.
Yes. When all the lights were going in this circle, we were getting a white patch. Yes? So, white is made up of? White is made up of?
Rainbow.
All the colors. Yes? And when there were no colors, then it was black. So can we call black as a color? No color is black. And all colors is white. Yes? So now can you tell me what kind of shadow do you see in daylight? Black. So what kind of light is daylight? White. Yes? All the colors is white. No color is black. So as you see white shadow, the light you are blocking is all the wavelengths, all the colors. Hence it is white. And your shadow is black. That is the reason why you could see some blue and red patches on the moon. We didn't wanted that. Hence, we used mirrors.
So you say there is some defect in my lens?
No,
Yes.
prisms,
Okay.
prisms and lenses tend to give that defect that is called a chromatic aberration.
Okay.
So, can we see the new telescope that we have with mirrors?
Yes. So I would like to see that. What is the change, revolutionary change that you are mentioning, and these people called Newton? Who is Newton?
Know about Newton.
Of course, I was dead by the time. No, I don't know about Newton.
Told the name of Newton.
She just told us the name of Newton, who she said has made some new telescope. What is this Newton telescope? New
So
telescope? Newton telescope.
people want much clearer, sharper, and bigger image, as I say. But with the lens, we can't do it very easy. Okay, the lens we want will be becoming big in size. Its weights become more. and then the telescope becomes not easy to handle. So Newton decided to use the mirrors, and as we see, concave mirrors we use in this telescope, and as on the honor, your telescope known as Galilean telescope.
Okay.
This telescope is known as Newtonian telescope. Okay.
Of course.
So this is also good. So this one is a Newtonian telescope. It is small in size.
Can I see it in better light here?
After that we will
Oh, you want to show. Then I'll come closer.
Newtonian telescope, which having a primary mirror at the bottom, which is concave in shape. Okay, and secondary mirror here, which is plane mirror. Okay, plane mirror, and which is aligned at a 45-degree angle. Okay. And this one is a focuser, and on the focuser we place the eyepiece from which we can see the object.
That is very clever.
3.5 meter telescope, and this one is a 6-inch in size. This mirror having a 6-inch in size. So this one is a bigger one. Okay. So as same as the Galilean telescope, you can see. Again, to use. What is this? Our water bottle. This is again a low-cost version of Newtonian telescope. So here, yes, water bottle.
You have flexible glass.
You can identify from this cap. This is water bottle. So in this, similar to that telescope, here is your concave mirror, and at this place you have a flat mirror, that is a plane mirror aligned at a which angle? 45 degree angle. And from here we can see, here is at your eyepiece. So I am putting this laser in this direction. Okay. So you identify where it goes. Can you see at the ceiling? Okay. And at this direction our eyepiece is, so you can see that our object is here. So light from the object enters through this open area. Okay. And falling on the first primary mirror, then reflecting back to the secondary one, and then again towards the eyepiece. So you can see okay.
Wow. Nice. So that is a clever use of mirrors. And I suppose it does the same job as a lens, because we wanted to focus light. The lens I used was to focus light, and this also focuses light to a point. Yes, so now I figure out that it should do the same work. That's very clever.
Now, if our friends don't have these equipments, maybe this glass plate or lenses, what is a simple thing they can use? They can use their rubbers in their boxes and some toothpicks to make a model of or a ray diagram of mirrors.
Let me hold one side.
So now, can you imagine this to be a mirror
Okay,
and this to be the light rays?
right.
Now we'll focus the light rays to them and show them what will happen to the light rays, which are parallel to each other now, as it is a plane mirror. What will happen to it when the mirror becomes concave? What happened to the rays? And what will happen if the mirror becomes convex? Yes?
Oh, this is so clear, and your magic torch and this has made it very clear. I wish I had learned like this when I was in school. So that is concave and convex surface. Lovely. What more do you have to tell me? Because I am still wondering about 30-meter telescope.
Yes. So, in a 30-meter telescope, we use mirrors, which is one primary mirror, which is as big as 30 meters, but it has segmented smaller mirrors. One mirror is equal to approximately 144 centimeters, which is approximately this much.
Yes.
You can imagine
Okay.
492 people on one big mirror.
Wow. That is a lot of people. I mean, that is a lot of mirrors.
So, this is a big upcoming 30-meter telescope project, and India is a part of it. So,
Oh, I wish the most wonderful success to this project, and I hope that this modern era, although I will not be there, I hope that the modern human beings get so much more information about the universe. I think now I will just disappear and go further into the future and see through the 30-meter telescope now.
Yes.
So thank you for showing me these beautiful things, and telescope boy, you have shown us a cutout telescope. That's very lovely. Thank you very much, and thank you all for listening to them along with me. Goodbye.
thank you all.
Actually, in this 1 minute, and came back with something special from 30-meter telescope. So now I have more things that you will get.
Galileo has become generous.
Okay, so here you go. This is a goodie bag from TFT. I also want to know what these telescopes are.
All of us who are here, I would like to give a big round of applause to the whole team of ISA and TFT for such a nice work. Thank you so much, Sangeeta and